Good morning, students. Good morning.
Good morning, ma'am.
Yes, good morning, ma. Okay, today we'll see the last topic for our next internals. Um, so you'll be having your internals from 20th onwards, right? So when is your TOC exam? Have you checked your timetable? Yes, no one has checked.
Twentieth.
20th. So first exam is TOC,
No, ma'am. It's afternoon.
afternoon. So morning you have another exam.
Yes, ma'am. Soft skills.
Okay, so we'll not have much time on that day, right? So you have to prepare it before itself.
Yes.
Okay, so we'll quickly see this topic and we'll try to revise the portions for the exam. Okay, so the next topic that we are going to discuss is that the membership algorithm for the context-free grammar. Okay, so this algorithm is called as an CYK algorithm by deriving its name from the people who have find out this algorithm. Okay, so the originators of this algorithm were, excuse me. So the originators of this algorithm is J. Koch and D.H. Younger, and then T. Kasami. Okay, so taking the first letter of their names, the algorithm is named as CYK algorithm. So this algorithm is, it states that it tells how to find out whether a particular string belongs to a particular language or not. Okay, so to when a string is given or when an input is given, to check whether that is a member of the language generated by the given grammar. Okay, so we have studied about the context free grammar and context free language. So when a string is given, okay, when a string is given, we need to just check whether it is a member of the language generated by the given grammar. Okay, so to identify the membership of the given grammar. Okay, so to identify the membership of the of any string, this algorithm is used. And the condition for this algorithm to work on is that the grammar should be in the context-free grammar should be in CNF form. I hope you remember what is CNF, right? Chomsky normal form. So what is the Chomsky normal form says? It should have only exactly two variables on the right hand side, or it can have a single terminal. Okay, so this is the condition for a Chomsky normal form. So only if the context free grammar is in Chomsky normal form, this CYK algorithm can be applicable. Okay, and so what this algorithm does is that to check whether the given string is a part of the language or not, or whether it is the member of that language or not, what it will do is it splits or it breaks that given string into substrings. Okay, so when a string w is given, okay, when a string w is given, it is this algorithm, it breaks it into substrings, or we can say that the problem is divided into sub problems. Okay, so it breaks the string into substrings, and it identifies the variables, identifies the variables that generate this substrings. Okay, I'll tell you with an example. So so when a grammar is given, you definitely know that a grammar is defined by VTSP, right? So you have a set of variables. So when a string is given, it is divided into substrings of various length. Okay, so first it is divided into one length substring, then two length substring, three length, four length, till the number of the up to the number of elements present in the string. Okay, based on the length of the string. So, for example, if you have a string W, say W is equal to A1, A2 up to AN. Okay, a string A1, A2, AN is there. Okay. Now this string has to be divided into many substrings. So, for how many? So, how will you divide it? For example, let me make it as a1, A2, A3, A4, A5. Okay, let me make this string as A1, A2, A3, A4, A5. So the length of this string is 5. Okay, so the substrings can be generated as first it is generated in the form of single length substring. Okay, so W11, that is equal to A1. Okay, then only the second thing. Okay, A2, then okay, so we are just splitting it with the single length substring, and then this can be subdivided into two length substrings. Okay, so that means how many substrings you will be able to make? A1, A2, okay, then A2, A3, then A3, A4, but this should be done in an order. Okay, only in this order, and then A4, A5. Okay, so these are all two length substrings. Then when you come to three length, okay, so A1, A2, A3, A2, A3, A4, okay, and then A3, A4, A5. Okay, so first three, then the next three, the next three. Okay, similarly you can divide it into four length substrings: A1, A2, A3, A4. Okay, so this is one substring, and then A2, A3, A4, and A5. Okay, this is another substring. Then finally, all together itself is a substring. Okay, the string itself is a substring. So now, the algorithm, what it does, it is going to break the given string into such substrings of various lengths, and it is going to identify the variables that is going to generate these substrings. Okay, identify the variables that is going to generate these substrings. So that will be taken from the given productions. Okay, so by looking into the productions, it will check whether this substring is generated by any of the variables. See, for example, if you have a production, say A gives A1, A2. Okay, if a production is available like this, then it means that this substring is generated by the variable A. Okay, so like this, from the given grammar, it is going to identify the variables that generate the substring. So after finding that, the entire length substring we are having, right? So in this, if you are getting a variable that belongs to the starting variable. Okay, so for this you will get some a variable list. Okay, variable one or more variables. So in that, if it contains the starting variable. Okay, so if yes belongs to this, we can in generalization I can say 1n. Okay, so or you can, for this particular example, I can say 1 5. Okay, that means from 1 to 5. Okay, so if in this particular substring, the entire string, if you are getting a starting variable as the variable, okay, in this, if it generates, if this substring is generated by the starting variable, then you can definitely say that the given string is a member of this, the given string is a member of the language generated by the given grammar. Okay, so this is what we are going to prove now. So do you understand this, ma'am? We'll see with an example. So do you understand the concept? No answer? So take down this problem. So let me give a grammar. Yes gives yes gives AB and A gives BB or small a, and B gives capital AB or B. So you can, as I told you, that this membership algorithm will be applicable only if the grammar is in CNF form. Okay. So now if you check, the grammar is given in the CNF form. Okay. So all the productions are having exactly two variables on the right hand side, or it has only one terminal. Okay. So this is in the CNF form. So now the string given is that we need to check whether the string W equal to AA BBB is a member of this language, is a member of the language generated by this given grammar. Okay, so if you are going to generate the sentences or strings using this grammar, you will get a language, right? You will get a string of set of strings for this particular language. So now they have given a string and asked us to check whether this string is present in the language generated by this given grammar. Okay, so to check this, as we have discussed, it has to be divided into many substrings of various lengths. So let us draw it as a table. Okay, first you write the substrings, write the string Okay, so based on this, we are going to draw a table. So in the first step, we are going to divide it into one length substring. Okay, so divide it accordingly. So now we have divided it into a single length substring. Okay, so A is a substring, this A is a substring, B is a substring, B. Okay, all these were all separate substrings. And then we can, so this gives you the thing. What is the substring name? This is 1 comma 1, this is 2 comma 2, this is 3 comma 3, and this is 4 comma 4, and this is 5 comma 5. Okay, and is it visible what I'm writing? Is it very small or is it visible? Is there anyone in the class?
Yes, ma'am, it's visible.
Yes, thank you, ma'am. Then we'll be dividing it into two length substrings. Okay, so that means 1 and 2 together. Okay, so 1, 2, 3, 4, and 5. So as we have seen earlier, 1, 2, then 2, 3 together, 3, 4, and 4, 5. Okay, so then we will get 4 substrings like that. So 1, 2 by combining these two, then 2, 3, then 3, 4, and 4, 5. Okay, and then we will be combining with 3 lengths 1, 2, 3, 2, 3, 4, and 3, 4, 5. Okay, so then we'll be only 3 substrings. So 1 comma 3, that means from 1 to 3. Okay, then 2 to 4, 2, 3, 4, then 3 comma 5, then that means 3 to 5. Okay, then we will be getting 4 length substrings 1 comma 4, from 1 to 4. Okay, 1, 2, 3, 4, then 2 to 5, then finally 1 to 5, the entire substring. Okay, so now we have made a table to have the different length substrings, and also we are going to identify the set of variables that generate these substrings. Okay, so variables that can generate this particular substring. Okay, and which variable could generate this substring. Okay, so that we are going to find out. So for finding out that, for the first 2 rows, it is very simple. You are just going to look into your grammar. Okay, so the substring given is A. Okay, so you check in the grammar whether A is generated by any variable. Okay, we have a production like that. So A gives small a. Okay, so this A is generated by the variable capital A. So you can put it in this particular box. And similarly, next also again small a. So again capital A. Then comes small b. So small b is generated by the variable capital B. Okay, so for all these you can write capital B. Okay, so now the next row. Okay, the next row, it is having all 2 length substrings. So what is 1 to the first 2 strings? Okay, but you take it from the previous row. Okay, take it from the previous row, not from the exact strings here, but from the previous row. So what is given? AA. Okay, capital A, capital A. So 1, 2 is the first 2, AA. So you check in the grammar in the given productions whether AA is derived by or generated by any of these variables. Okay, no, it is not available. Okay, so just put a phi symbol. Okay, there is no variable that generates AA. Then comes 2, 3. 2, 3 means this and this. Okay, so the second row you are going to write it based on the first row. Okay, the first row you are going to write directly based on the given string. Okay, so 2, 3 it means AB. Okay, now you check in the production list whether AB is generated by any variable. So there are two variables that generate AB. Okay, one is S and another one is B. Okay, S generates AB and again B also generates AB. So that means you write both S and B. S comma B. Okay, then 3 4. So 3 4 is BB. Okay, you check whether BB is generated by any variable. So BB is generated by variable A. Okay, so then you write A here. Then 4 5. 4 5 means again BB. So BB means it is generated by A. Okay. So now, so far, the first two rows, it is very easy. You can directly write like this. Now, coming to the next row, since it involves it involves three length substring and all these together. Okay. So how we are going to find out this is you take, so to find out this particular for this particular substring, what are the variables that are generating this substring? You are going to take the rows that are above that, okay, and also the rows, the variables that are present on its diagonal, okay, the variables that are present on its diagonal. So to this particular cell, what is the variables that are present just above that and what are all the cells that are present on the diagonal of it? Okay, so this one, okay, the diagonal as well as the variables that are above that. Okay, so you just write it like this. So for 1 comma 3, okay, you 5, okay, this one, and on this side what you're having, B and S comma B. Okay, so write it like this, and what we are going to do is we are going to just make a combination out of the given variables. Okay, so the combination has to be done like the first one has to be combined with the last one and the last one has to be combined with the first one. Okay, so in this case it will be like this. When you go down, when you be getting more number of variables. Okay, so I'll tell you how to do that. So now how you have to do this is you have to exactly write in the order in which the variables are present. Okay, so A is combined with S to get AS, then A is combined with B to get AB. Okay, 5 when it is combined with any other variable, it is again 5 only. Okay, so it is empty. So AS and AB are the variables you are getting now, or the productions you are getting. So now you check in the production whether AS is generated by any variable. No. Okay, then you check whether AB is generated by any variable. Yes, we have S and B. So that means S and B generate the substrings of length 3. Okay, for string 1 to 3, and then comes 2 to 4. So for 2 to 4 again the same thing. Okay, so you take the variables above this cell. Okay, A and S comma B and this cell. Okay, you have to write it from the top to bottom, B and A. Okay, and now you cross it. So what will you get? AA. Okay, and then S is combined with B to give you SB, and then B is combined again with B to give BB. So now find out what are all the things that are generated in this given production. AA is not available, SB is not available, but BB is available. Okay, so only BB is present in the given production and that is generated by A. So that means you put A here. Okay, and then comes the next thing. So for finding this one, you take this two cells and the diagonal of this thing. So what will you get for 3 comma 5? You are getting B A, and then again here also BA. Okay, BA, and this diagonal also BA. Okay, so now again cross it with each other and find out what are all the variables BA and AB. Okay, so you have to write it in this order only, BA and then this combined with all these things, AB. Okay, so again we can see AB is available in the given production and that is generated by S and B. So this cell will be getting S and B. Okay, do you understand this map to this? Can I get some response? Yes or no? Yes, yes, thank you, ma'am. So now for finding again 1, 4, the same thing. Okay, now you have to take all the 3. Okay, all the 3 cells above this and all the diagonals for this particular cell. Okay, so that means what are all the variables will be getting? A, 5 and S comma B, and then here diagonal to this is B, A. Okay, you have to take it from the top, B, A. Okay, so now when you are crossing it, the first one has to be mapped with the last one. Okay, and second one will be mapped with the one previous to the last one. Okay, and this will be mapped with the first one. So now you write down all the combinations A. Okay, 5 and combined with A, again it is going to be 5, and then here S combined with B, SB, and then BB. Okay, so similar to what we have got here, right? So AA is not available, SB is not available, BB is there. So for BB, it is generated by A. Okay, so this cell will get the variable A. And then 2, 5. So for 2, 5, what are all the variables you have to take? A, SB, A. Okay, so write it A, SB, A. And here the diagonal is BASB. Okay, BASB. So BASB. So again cross it, find out the combinations AS, okay, and AB. Okay, this has to be combined with both the variables, first AS and then AB. Then here SA, order should not be changed. You cannot write SAS, AS. Okay, BAS, AB. Both are different. So SA, then BA, then AB. Okay, so as we know, AS is not present in the production list. SA is not there, and AB and AB is available. Okay, but BA is not there. Okay, so for AB, we have 2 options, S and B. So it is generated by both S and B. Okay, so finally coming to 1, 5. So all these things you can write. Okay, so let me write it here. A, 5, S comma B and A. Okay, all the 4 cells, and here all the diagonals. Okay, for this the diagonal is this one. So B, A, S comma B and S comma B. So let us again map it. So the second one will be mapped with the one previous to the last one, and this will be mapped with this to the first one. Okay, so as you write, it becomes the combinations will be AS, then AB, then 5 when combined with anything, it is going to be 5. So we will leave it. The next one, SA, then BA, then AB. Okay, so again all other options is not available, only AB is there. AB is given by again S and B. Okay, so now we have filled this table. What we need to check, whether this variable set present in 1, 5. Okay, so variables that are present in 1, 5, whether you are getting starting variable in that set. Okay, so what you have to write, since S belongs to V 1 5. Okay, in this variable list there is the starting variable. So since S belongs to V1 5, we can say that the string W is equal to AA BBB is a part of the or belongs to the language generated by the given grammar. Okay, so this is the CYK algorithm to find out the membership of a particular string. Okay, do you understand this, ma? Can I get some response? Are you all listening? Taking down? Yes, yes. Thank you, Johnson, Gibson. Yes, thank you, ma. What about others? Every time only 2 or 3 are responding. I'm not sure whether all others are listening or not. So, from starting from regular grammars, we have it for the exam. So let me quickly go through some of the things. I'll just give you what you have to prepare and so on. So we have portions starting from regular grammar. Okay, regular grammar. Then we have studied the equivalence with finite automata. Okay, how to convert from regular grammar to finite automata and finite automata to grammar. Okay, and then we have studied the properties of regular languages. Right, the which are all closed under regular language. Then we have studied the right quotient. Okay, so all those properties you need to study, and please make a note whatever I'm telling you. See, last time some around 10 to 12 have got very border marks. Okay, not even you have passed. So this time I don't want to be like that. I want every one of you to get good scores in the second internals, because as you know, you'll be taken only best 2. Okay, so those have scored less in the first internals, so please try to concentrate more and try to get good scores in the second internals. And so we have to study for you have to study the properties, and then pumping lemma we have studied, right? The pigeonhole principle, the pumping lemma thing we have studied. So you just go through the I'll try to share the PPTs also in the Google Classroom. Study all the definitions, okay, especially because we have been defining several things, like we have defined right linear grammar, left linear grammar, what is a regular grammar, and then what is simple grammar, context free grammar. Okay, and then what is ambiguity, what is Grayback normal form, what is Chomsky normal form. So we have several definitions for this. So be thorough with all the definitions. So definitions in the sense, so you will be because since we are having all choose the best answer and match the following. So true or false. So you should be knowing very thoroughly for which definition which thing will come. Okay, so for everything you will be studying like where so the format of the grammar should be like this. Okay, A gives AX. Okay, where X belongs to the terminal, or X belongs to variable star. Okay, so for various things you have some differently. So write it down and study it. Okay, because as it is all one word answers, will not be able to give you all the detailed answers, right, like this, right? So you should be concentrating concentrating much on even the very simplest things. Okay, so the definitions are important, so please study all the definitions carefully. And when you are asked to so please be careful in choosing the answers. Okay, So don't rush and write wrong answers. So you need to know, we have studied about the grammars in terms of right linear, left linear. So the definition along with an example. So how the grammar will look like, how a right linear grammar will look like, how a left linear grammar will look like. Okay. So I just go through the definition as well as the examples. And then we have studied the pumping lemma, right? So why we have studied pumping lemma? To prove that a language is regular, is not regular. Okay, to prove a language is not regular. So if questions are asked based on like whether to identify whether the given language is regular or not, so immediately you go on to apply the pumping lemma. Okay, you take a sample string in the given thing, and you try to apply the pumping lemma. So you need to study the pumping lemma. So pumping lemma, we have studied that each string will be divided into 3 parts, x, y, z, and the middle part will be pumped for all variables, for all values of I equal to 0 to etc. Okay, so you apply and see whether it is a part of that language. So then you will be able to say whether the language is regular or not. Okay, so for such problems, you immediately move on to apply the pumping lemma. And then we have studied the context-free grammar and context-free language. So for if a grammar is given and asked to match it with the languages, then you should know how to do that. Okay, you can so when a grammar is given, you will be able to derive the strings or sentences out of that grammar. So based on that strings, you should be able to identify what language it is. Okay, so when options are given, you try with the given options what is the best one that is matching with the given language. Okay, and then you have to be thorough with all your ambiguity. We have studied about the ambiguity. So be thorough with all the definitions for parsing this derivation tree. Then there we have seen leftmost derivation, rightmost derivation. Okay, so be thorough with all these definitions. And ambiguity, as you know, I hope you remember what is ambiguity. Okay, if you have more than one derivation tree, if you are able to draw more than one derivation tree, or if you are able to draw more than more than one leftmost derivation, okay, or if you can have more than one rightmost derivation, then the grammar is ambiguous. Okay, so please be thorough with that definitions. And we have studied about simple grammar. Okay, so check how a simple, what is the definition of simple grammar, what is how to how a simple grammar will be looking like. Okay, so all those things you study. And then we also have studied about the simplification part, right? How the context-free grammar can be simplified. So the we have seen how to do the unit removal of unit production, then useless symbols. Then we have studied about the nullable variables, or the lambda production, removing lambda productions, right? So all these things you check what are all the definitions and how to do that. Okay, so check everything. And then this CYK algorithm, okay, what we have studied, that also you study well. And so then Chomsky normal form, Grayback normal form, what else, any other questions missing? So all these everything you first study the basic things very thoroughly. Okay, because you're not going to solve the whole problem. Okay, so the basic things you should be very thorough, and only then you will be able to solve and give the right answer. Okay, and this all this simplification part, you be thorough. As I told you, first the lambda production has to be removed, followed by unit production, followed by the removing useless symbols. So when if a grammar is given and asked you to do that, then you should be able to match everything correctly. Okay, you should be able to identify what the correct answer for after removing nullable variables, or after what is the useless symbols. Everything you should be able to identify properly. Okay, and I think that's all. Only this much portion we have it for now. So please study well and do the second internals very well. And I want all of you to get good scores in the second internals. Okay. So last time it's not so good because of course most of you have scored good marks, but still some 10 to 12 have got less than the border. Okay, even not even the pass mark, so it should not be there. So study well and prepare well for the second internals. If you have any doubts, you can just ask me,